Hello, everyone. You are welcome to today's lesson. And in today's lesson, we are going to continue from where we left off. Okay, and we are still on the topic calculus, but in particular differentiation. Okay, even in differentiation, remember our last meeting, we were looking at the rules. Okay, and we considered the last version or, yes, part of our rules. Okay, which is what the composite function rule or, okay, the chain rule. Okay, so we did all the questions in worked example 1. Okay, you have worked example 2. And if I go back to worked example 1, you realize that in worked example 1, okay, the exponent of your function to a certain power that you are asked to differentiate, okay, all of them were pretty integer values, okay, positive integer values. Now, okay, we are going to look at situations where your exponent will not be that pretty. Your exponent could be fractions and it could be negative integers as well. Okay, so please stick and stay with me whilst I walk you through, okay, our second worked example. Okay, and if you are here to subscribe to my YouTube channel, okay, please do so now for more content like this. Okay, so let's look at the worked example 2. Worked example 2, let's read the question, get to know the demand of the question, then we'll know exactly what to do. So question 2, we are supposed to find dy, dx for each of the following. So once we are asked to find dy, dx, you know, we are differentiating. And in differentiation, I've told you we should always know our differential operator. So if you look at this carefully, once we are finding dy, dx, what do you think will be our differential operator? Hello, my professors, can you hear me? What do you think will be our differential operator? If you have dy, dx, what is the operator? Hello, can you hear me?
Yes, please.
Hey, let's start well. What is the operator?
Your wife.
The operator is what?
DDX.
ddx. Okay, so that's the operator. So because, and this is x because your y depends on x. So it means, okay, indeed, we can differentiate y with respect to x. So we are finding ddx of all the functions that we have here. And once we have dy dx, it means, okay, all the functions strictly must be labeled y so that we can find dy dx. Okay, so in this case, I write my major question number. So question number 2. Okay, question number 2. Then I come to my minor question number, and that is A. Okay, A, what am I giving? Y is equal to what? Okay, in brackets 2x, okay, plus 3, the whole of that to the power half. Okay, so now remember the rule for the composite function differentiation. We were told in our previous meeting that anytime you have a function to any power, okay, and that function contains more than a term, okay, obviously the rule that should come to mind should be the composite, okay, function rule or the chain rule. Okay, so in this case, what do we do? The rule says, so it means I'm supposed to take d dx of both sides. So if I take d dx of y, that will give me dy dx. So it means the question, directly asks you to find dy dx. So dy dx, okay, I know will be equal to d dx, and it will not be dy dx of this, please. It's d dx. So that's your operator. Okay, then of what? Your 2x plus 3, okay, the whole of that to the power half. So now you ask yourself, your operator is affecting a function to a certain power, a binomial function to a certain power, though the power is not pretty, but it's the same rule that we are going to use. So my next step, okay, what do I do? Bring the power down, the exponent down. So that will give me half. Okay, then I keep my function, which is the 2x plus 3. Then what do? I reduce the exponent by 1. So half minus 1 will give me minus half. Do you agree?
Yes, please.
Okay, then that is not all. Times okay, the derivative of the function raised to the power, you remember. So d dx of what? The function, okay, that you have in brackets, which is your 2x plus 3. All correct, my professors.
Yes, please.
Okay, so that is the rule. So in this case, okay, this is going to give us, okay, 1 over 2. Okay, you keep whatever that you have here into, okay, 2x plus 3, all to the power minus half. Okay, but that is not all. The whole of that times, okay, if you differentiate 2x plus 3, what do we get?
2.
2.
2.
You get 2.
Yes, just
Okay, so you get 2, so in times 2. You put it in brackets. Okay, so now you know you can multiply half and 2 easily. Okay, you have 3 factors. One factor is half. The other factor is 2x plus 3 to the power minus half. And the last factor is what? 2. But the first factor and the last factor, you can multiply. So if you multiply the 2, we'll cancel this 2. So in effect, we are going to get this to be equal to what? 2x plus 3 all to the power negative half. Do you agree?
yes, please.
Okay. Okay, so hello, Prof. Gideon.
Sir, please. Sir, please, can you explain it again?
Hello, come again.
Sir, please, can you explain it again?
From where?
The previous. I said, please, from sir, please, the last part one step. Sir, please,
The step.
Yes, sir.
So you understand the step?
Sir, please, no. Yes, sir, please, I understand that, sir.
You understand the step. Okay, so you keep this one. That's what I've kept here. You are differentiating this. If you differentiate 2x plus 3, what do you get?
Sir, please, you get 2.
You get 2, so that's what is here. So it means now this step is okay, right?
Yes, sir.
Okay, so you have A times B times C. So you can multiply half times 2. You know that this 2 is a numerator, this 2 is a denominator, so they can cancel.
Yes, sir.
Only that I didn't show the cancellation. Remember, I've told you can do the cancellation mentally.
Yes, sir.
Okay, and so if this cancels that, it will be 1 times the whole of this times 1, which will be, okay, only this. So that's exactly what I have here. Is that clear now?
Yes, sir, please, thank you.
You are welcome. Okay, and if you don't want to conclude with what do you call it? A negative exponent. Someone can go ahead and write this. So let me write or, okay, then you know this is the same as 1 over, okay, what do you call it? 2x plus 3 to the power half. Do you agree?
Yes, sir.
Okay, and someone can also write it as, okay, or 1 over root of 2x plus 3. Do you agree?
Yes, sir.
Okay, please, do you all agree?
Yes, please.
Okay, yes. All right. Okay, Ernest, are you around? Okay, Prof. Carol.
Mr. Hackman, please. I want to ask if the first answer was correct.
Yeah, this one.
Bracket 2x. Yes.
This one. Yeah, it's correct.
Yes.
Once you see also,
Okay.
it means any of them will do. Okay, but my point, you know that in indices, usually would ask you not to conclude with a negative exponent.
Yes, please.
However, if you leave it this way, because it's not pure indices, that's okay. Okay, you can end here, okay, and or end here. But if you are supposed to end with a root sign, remember I told you, then it means the question itself should have that sign in play. Otherwise, you avoid.
Yes.
Okay, so remember I've told the nature of the question will indirectly guide you as to how you can leave, okay, your final answer, how far you can go. Or you must go.
Yes.
Is my point well made, my professors?
Yes, please.
Okay, so we are going to do more, don't worry. Okay, you all, okay, unless you don't want to ask questions, you know, I've told you, I'm here because of you. So now let's go and look at the B. Okay, B, what do we have? Again, we've been given y is equal to, okay, this time around we have 3x squared, okay, then minus 2x, the whole of that to what power? 1 over 3. So with this one, you can see that I think I should have said this from the beginning, but it doesn't change anything if I say it here at this point. Okay, if you look at the first one, okay, no matter what in this question, unlike the first set of questions, here, we could have avoided the composite function rule or the chain rule because we can expand this, we can expand this, we can expand this. Okay, in fact, all of us should be able to expand all the functions that we have here. Okay, only that I've told you if the exponent is up to maybe 3, that's where the expansion should come in handy. Otherwise, use the power rule. But with this one, so it means here we have 2 options. If the question didn't restrict us to the method to use, okay, be it the composite function rule or you expanding and differentiating term by term, you have 2 ways. But when it comes to this, okay, you are restricted indirectly, okay, to use the composite, function or the chain rule. Because, okay, anytime when we're dealing with binomial theory, we are told that if the exponent is negative, it's fraction, okay, you should know that you wouldn't be able to expand and give us all the terms. The expansion will give us an infinite number of terms. So if you don't know all the terms, how do you give us the differentiation of each term if you expand? You get a point. So it means you cannot use the expansion in this situation. So you are compelled to use the composite function rule. Point well made, my professors.
Yes, please.
Okay, so at this point, what do? We are going to get d dx. We know our operator d dx of y, we know will give us dy, okay, dx. Okay, and that should be equal to d dx of the side. Okay, so which is what we have here. Okay, so 3x squared minus 2x all to the power 1 on 3. Okay, so at this point, this will be equal to, okay, so my operator is affecting a binomial to a certain power. Okay, so power rule, or what I mean we are dealing with here in terms of what? The composite function rule. Okay, with the power rule, the constant that the factor that you multiply will always give us 1. But with the composite function rule, okay, it will not always give you 1. So now let's go and look at what we have there. If I'm supposed to differentiate, I bring the power down. So 1/3 will come down. Do you agree? So deal with it the way you deal with normal differentiation. Keep your factor in brackets. So we have 3x squared, minus 2x. Then reduce the exponent by 1. So 1/3 minus 1 will give us
minus 2/3.
Minus 2 on 3. Very good. Okay, but remember that is not all times d dx of what you have in bracket. So d dx of what we have in bracket, the function that you have raised to the power, which is the 3x squared minus 2. All correct, my professors?
Yes, please.
Okay, so you remember the first 2 factors that we have here, no operator is affecting it, so it remains the same. So 1/3, then the 3x squared minus 2x, to the power minus 2 on 3 intact. Okay, then times. Now we are going to differentiate. This is 2x. I left the x. Okay, I'm sure maybe going forward, one of you would have drawn my attention to that, which I know you are very good at. Okay, so now what do we have here? Okay, we are going to differentiate term by term. So if you differentiate 3x squared, what do we get?
6x.
6x. Okay, if you differentiate minus 2x, what do we get?
Minus 2.
Minus 2, not 2, be careful. But because it's a binomial, we have to put it in brackets. Other than that, we are doomed. Afa?
Yes, please.
Okay, so you can clearly see that, if I'm supposed to rearrange, I'm going to rearrange. This I have 3 factors. 1/3, this factor, and this factor. But if you look at the 3 factors, 2 of them are pretty. This factor and this factor are pretty. Or this is a monomial factor, a binomial factor, a binomial factor. But this binomial factor is prettier than this. So I'm going to rearrange. Remember, the point is to multiply this and this. Okay, but I'll rearrange before multiplying. If you are smart, you can skip the rearrangement step. Okay, so it means I'm going to get this to be equal to 1/3. Okay, I'm bringing this one next. My next prettier, what do you call it? A factor. So 6x minus 2. Okay, then into okay, 3x squared, okay, minus. So you know multiplication is associative, so we can rearrange. Okay, so to the power minus 2 on 3. Alpha, all correct?
Yes, please.
Okay, so we know, okay, so Prof. Gideon, let me land. So now we know, okay, that this, okay, and this, okay, I can easily multiply. So it will be 1 over 3 times, okay, 6x, and that will give us, okay, 2x. Do you agree? Okay, and 1 over 3 times minus 2, and that will give us minus, okay, 2 on 3. Okay, I close my bracket and write this again. All correct, my professors.
Yes,
Yes,
please.
please.
Okay, so Gideon, you may now come in. You have the floor.
So please, yeah, the last step that contains the 1 over 3, you differentiated the 3x squared minus 2x.
Which one?
So please, yes, that one. So please, you differentiated it.
I differentiated what? No, I've not. The differentiation was done here, and that gave us this result. So after that, you don't differentiate again. Other than that, you are doing multiple differentiation. The question is asking us to differentiate only once. So per the rule, this will be, you bring the power down, keep this, reduce the exponent by 1, then that's not all, times the differential of what we have in brackets, okay, which is the ddx of this. Okay, so this one will be kept intact. That's what I have here. Come and differentiate this. That gives us what we have here. But I'm only rearranging. If I have A times B times C, I can write it as ACB. I can write it as BAC. I can rearrange because you know multiplication is associative. So I
Yes, sir.
only rearrange. I only brought this one here. Okay, so 1 over 3, this is PTR. I brought the 6x minus 2, then, okay, kept this one, okay, 2. Then I said we can multiply, okay, just as we've been doing. The factors that we can easily multiply, we multiply. So this and this can easily multiply. So 1 over 3 times 6x will give us 2x. 1 over 3 times minus 2 give us minus 2 on 3. Remember, okay, you are pushing this one in because it's more than a term. The bracket is critical. So you put it in bracket, and that gives us this. Points well made now.
Yes, sir. Thank you.
Okay, you are welcome. Okay, so we have 2 more to go. If you look at the next one, okay, I won't talk much. Okay, at the point, maybe give you 1 or 2 info, and you realize that we are dealing with the same question put in a different form. So let's look at the C. Okay, C. What are we given? Y is equal to, okay, root of what? 2x, okay, plus 3. Okay, one of the basic rules of differentiation, you know you are differentiating, okay, but you know that one of the basic rules of differentiation is that our power must be explicit. Is that clear? Remember, I've told you, okay, can we, do we have explicit power in terms of what? Our 2s plus 3. The power is not clear. Okay, it's not directly given, but we know we need the explicit one. So I have to transform this before working on it, as I've advised you. I'm very consistent. So this will be equal to, okay, I know this is the same as 2x plus 3 all to the power half. Do you agree?
Yes, please.
Okay, so you can see that now, okay, these two are the same questions, but put in a different form. Okay, this one, the exponent came in its explicit form. This one, no, you have to make the exponent explicit before you can go and apply the composite or, okay, the composite function of the chain rule. Point well made.
Yes, please.
Okay, so at this point now you go and have, okay, you are taking d dx of both sides. So d dx of y will give you, so I can write, therefore, dy dx, okay, will be equal to d dx of what I have here. So d dx of what? Of 2x, okay, plus 3 all to the power half. So it takes us back to what we were dealing with. Okay, so this one. So from here, okay, the solution will be the same. Point well made.
Yes, please.
Okay, so I don't have to, repeat myself. Also, you understand that you should be able to continue from there, right?
Yes, please.
So you continue equal to, you come and continue. So let me go and look at the D, or let's look at the D together again. So D, what do we have? Y is equal to cube root of what? Of 3x squared. Okay, then minus 2x. Okay, so again, you can see that the function 3x squared minus 2x, okay, the binomial here, its exponent is not, clear, explicit. So what do? We go and write equal to, make the exponent explicit. So 3x squared minus 2x to what power? The whole of that to what power? My professor says the whole of that to what power?
1/3.
1/3.
1 over 3. Okay, remember your indices. Okay, a to the power, root of nth root of what? A. Okay, is equal to a to the power 1 over n. So our n here is 3, so it will be 1 over 3. So in this case, I'm going to take d dx of both sides. So you can see that now the question, is the same as this. Okay, the b. Okay, only that it came in a different form. So now you have dy dx, will be equal to your d dx, of what? Your 3x squared, minus what? 2x, all to the power 1 on 3. So at this point, the solution becomes the same as what? The b. So you continue. All correct.
Yes, please.
Hello, any questions at this point before we move on to the next one? I'll work the example 3. Wow, we are all fine. We thank God. Okay, so if that's the case, let's move on to work the example 3. Okay, so work the example 2, you realize that we dealt with exponents that involve fraction, but they were positive fractions. Here in the example 3, if you look at it critically, you see a negative, integer values, as our exponent, and negative what? Fraction, values, rational what? Numbers. Okay, if I should so put it. Okay, so now the same concept. What are we supposed to do? Differentiate with respect to x. Okay, the following. Okay, so we know once we are asked to differentiate with respect to x, it means our operator is d dx. Agreed?
Yes, please.
Okay, so now what do? Write your major question number, then you come to your minor question number A. Okay, what are we given? Y is equal to what? In bracket 5x squared, minus 1, all to the power minus 1. Okay, so we are dealing with where your exponent is negative. Okay, whether it's a negative integer or a negative rational number, it's negative. So now what do? Okay, we are finding d dx of both sides. So d dx of this side will give us dy dx. Okay, and that will be equal to d dx of the side. Okay, so I keep it, that is what? 5x squared minus 1, all to the power minus 1. All correct?
Yes, please.
All right. Okay. So very good. So now the same rule. Don't stress yourself. My next step, I write close to the margin. So per the rule, what do? I'm supposed to bring the exponents down. Deal with it the way I'm dealing with the power rule. Bring the power down. So minus 1 will come down. I'm writing it just for explanation purposes. Okay. Otherwise, if you are mature, you write it. You are mature, so I won't write it. It's simply the 1 is simply understood to be there. Is that clear? So I'll write minus, I won't write the 1. The 1 is simply understood to be there. Then I'll keep my 5x, squared, then minus 1. And it will be minus 1 minus 1. That will give us minus 2. Do you agree?
Yes, please.
But that is not all, times d dx of what you have in brackets. So it will be d dx, of what? 5x squared minus 1. All correct, my professors?
Yes, please.
Okay, very good. So at this point, we are going to have this to be equal to, okay, this one will be kept. It's this function that we are going to differentiate. So you keep your minus in bracket 5x squared minus 1 all to the power negative 2. Then you come and differentiate. If you differentiate this, we are going to get, if you differentiate 5x squared minus 1, what do we get?
It's 10x.
10x. Please, do you all agree? So it will be times 10x.
Yes.
Okay, then you close your bracket. Okay, so you know this minus 1 and the 10x can easily multiply, and that will give you minus 10x. But because it's just a monomial, I can choose not to put it in bracket. So I'll write minus 10x, okay, the whole of that into 5x squared, okay, minus 1, okay, all to the power negative 2. All correct, my professors?
Yes, please.
Okay, and here, because the question itself has negative exponents, you can leave your answer in the negative exponents form. Remember, let the nature of the question guide you as to how best to leave your answer. Afa?
Yes, please.
Okay, all right. So we are going to move on to the B. Okay, so let's do maybe, okay, so with the B, the whole class, you are going to help me do it. So we have given f of x, okay, is equal to what? X minus 2x squared, okay, then to the power negative 3. Okay, so let's do it together. What's our operator? We determined the operator from the beginning.
F prime of x.
No, your operator is not f prime of x.
ddx.
ddx. So we are finding ddx of f of x, which will give us what?
F prime of x.
F prime of x. So remember, please, let's all talk, okay? All right, so who will be equal to, then you come and take ddx of the side. Okay, so ddx of what? X minus what? 2x squared. Okay, the whole of that to the power minus 3. Okay, so this will be equal to, what did we
Minus
do?
3.
Okay, we bring the power down, which is minus 3. Oh, the way class, let's go.
Bracket x minus 2x squared. Bracket
Okay,
close.
x minus 2x squared. The whole class, I'm hearing only one voice.
Times ddx of
No,
the function in the bracket.
no.
A raised to the power negative 3.
Where's the power?
Negative 4.
Minus 3.
Minus 4.
Minus 2. Minus 2.
No. Minus 3 minus 1.
4.
Minus
Minus
4.
4.
Minus 4. Be careful. Oh. All right, so minus 4. Okay, then times ddx of what you have before. So ddx of what?
X minus 2x squared.
Very good. All right. Okay, so please get involved. Let me hear your voice. If you are wrong, okay, definitely you'll be corrected, then you learn. Okay, so now our next step equal to, okay, so this will be kept. You are not, okay, so minus 3, okay, into x minus what? 2x squared. Okay, then let me write the squared well. Okay, into what? Minus 4. Okay, sorry, to the power minus 4. The whole of that times. Okay, if you differentiate this, what do we get?
1
minus
4x.
4x,
4x.
very good. Okay, so 4x. Okay, very good. So now how many factors? 3. Minus 3, this factor and this factor. But you can see that these two factors, minus 3 and this, are pretty. The power here is 1, the power of 4. So now what do? We can easily multiply. So if I'm multiplying, I'm going to get minus 3 plus 12x. Do you agree? Okay,
Yes.
however, remember I've told you, if you have an expression and you have a positive, you write the positive first. So I'm going to write a 12x first, then minus 3. Is that clear?
Yes, please.
Okay, then into, don't forget this. You multiplied the first factor and the last factor. This second middle factor is still there, which is your x minus what? 2x squared, all to the power negative 4. Okay, Prof. Caroline.
Mr. Ackman, please, after the step before the final step, the last step you just wrote. Sir, please, can you write minus, like, can you exchange the two terms?
Can you rearrange?
Yes, like
Just as we did in one of them.
Yes, please.
Remember when I was rearranging, remember I told you that step you can ignore as you mature.
Okay, sir.
Okay, so I'm showing maturity in this one once you've been told.
Okay, sir. Thank you.
Okay. Okay, Prof. Frank. Come again.
That in question 3, you interchange the final answer to be 5x squared.
He said I should change the final answer. Which one?
Positive 10 to the first.
Which one? The A, B, which one? Which question? Frank, it seems your network is bad. Your line was breaking. Okay, so you can come again when you have a stable network. Okay, I will go back and deal with it. Okay, Prof. Echo.
So please, I think I was trying to say that the final answer of question 3A. So you started with a negative expression.
I started with a negative expression. Okay, I do get what you are trying to say. Listen, okay, what we have here is just one term. Do you agree?
Yes, sir.
It's a term. Okay, however, what I was going to write, that's the -3, okay, then plus the 12x. How many terms? 2. Okay, so if you have more than a term, that's where you can determine whether I can start with positive or negative. But if I have only one term, I don't have any choice to start with what's negative, if the term is negative. Do you get the point?
Yes, sir.
So that's the more reason why if you have A times negative B, okay, do you leave your answer this way? This one term, you always have to write the negative first because there's a factor, there's a term. Okay, the whole of this is a term. Only that you have, okay, what you have there in factors. Okay, so it will be minus AB. Okay, as simple as that. Point well made. If you have A, okay, minus A maybe times, okay, sorry, maybe A times what? Minus in bracket B plus C. Is this not the same as minus A into B plus C? It's just a term, okay, but you have to bring the negative first. Papa, the explanation is okay, right?
Yes, please.
Okay. So the main point is that this is just a one term, okay, and this factor is a one-term factor. So if it is negative, I don't have a choice to start with negative. However, this is a two-term factor. So I cannot write if that doesn't mean if you write it as okay, -3 plus 12x, okay, will mark you down. But it doesn't show maturity. You can see that this is not compared this one and this one, which one is prettier? This one and this one. Obviously, the first one. So when you have an expression, you know the rule. More than a term, if you have a positive term, okay, start with a positive term. If the -12 was negative, then we are left to no other option than to start with a -3. So you write -3 minus 12x. Okay, so that one you don't have a choice than to start with a negative term because you don't have any positive term to start with. All correct, my professors. Is my point well made, my professors?
Yes, please.
Okay, all right. So now I think, okay, at this point, okay, let's see. Okay, between C and D, which one should we do?
C.
C. Okay, so I'm going for C, then you use the whatever the explanation to do the D. Okay, so now let's see what C has for us. Okay, so C, what are we giving? G of X is equal to what? Okay, 3x minus 1 all to the power minus half. Okay. Okay, I would have gone for D because if you're able to do D, you should be able to do C. Okay. All right. So now what do we have? We are taking d dx of both sides. So d dx of g of x will give us,
G prime of x.
okay, so g prime of x, okay, is equal to d dx of the side. So d dx of the side, okay, which is what? 3x minus 1 all to the power minus half. Okay, so the next step equal to, okay, bring the power down, so minus half down. Do you agree?
Yes, please.
Okay, keep your 3x minus 1. Okay, then reduce the exponents by 1. So minus half minus 1, minus 3 on 2, right?
Yes, please.
Okay, but that's not all, times d dx of what you have in brackets. So d dx of what we have in bracket, which is what? 3x minus 1. All correct.
Yes.
Okay, so let me see whether I created an extra group for. Oops, I didn't. Okay, so please, okay, let me quickly do that. Okay, then we come and continue. So let me pause. Okay, so if you look at where we are coming from, so we are going to keep this, then come and multiply it by the differential of this, which you all know will be 3. So I'm going to write minus half. Okay, so let me move on to the next page. So if you continue your next step, okay, our result is going to be minus half. Okay, then what? 3x minus 1 all to the power minus 3 on 2. Okay, but that times d dx of what you have in bracket, that is the 3x minus 1, that will give us 3. All correct?
Yes, sir.
Okay,
Yes,
so
please.
this, okay, you have 3 factors. A constant factor minus half, a constant factor, okay, 3, then what? This factor, but these two constant factors, we can easily multiply. So we are going to get what? Okay, minus 3 on 2, because we get half times minus half times 3, and that will give us minus 3 on 2, then into 3x minus 1, all to the power minus 3 on 2. Afa. All correct, my professors.
Yes, sir.
Yes, please.
All right. Okay. So so it means D, I'm not going to touch it. Between E and F, which one should we do?
F.
We should do F.
Yes,
Okay.
please. F.
Okay. All right. That's okay. They are of similar nature. Anyway, this is quadratic, this quadratic. The other one, I said this because this is quadratic, this is linear. Okay. And that once it's the bigger your function, the more work that you have to do. And you know that the size of a function, okay, a polynomial function is decided by, okay, or determined by its degree. All right, so now let's look at what F you said. So I leave a line, then I come to F. F, what am I giving? F of x, okay, is equal to what? Okay, 4x, okay, minus x squared, okay, all to the power minus 3 on 2. Okay, so here we go. We are asked to find d dx of both sides. So someone can come and write d dx of f of x is equal, then later go and write f prime of x. It will be a waste of time. You write a little more. So we know that d dx of f of x will give us f prime of x. So we write it straight away. So f prime of x will be equal to d dx of the side. So d dx, okay, of what? Your 4x, okay, minus s squared, all to the power minus 3 on 2. My professors, I hope you are following.
Yes, please.
Okay, so now your operator is affecting a binomial, okay, to a certain power. So composite function rule. Okay, so what do we get then? We are going to get is equal to, okay, bring the power down, so minus 3 on 2. And let's do it together. Into what?
4x minus x squared.
minus x
Minus
squared.
s squared. Okay. Then times d dx of what?
No, please.
Times d dx of what?
So you forgot the exponent.
Sir, please, you forgot
Very
the
good.
exponent.
Very good. So, Carol, it means now you are alert. Okay, so the exponent must be reduced by what? 1. So that will give us minus 3 on 2 minus 1.
Minus 5 on 2.
Okay, so minus 5 on 2. So let me go and clear that. Okay, knowing that I was tricking you, I should have moved this one, okay, to this side so that I wouldn't have to erase it. Okay, so minus what? Okay, 5
on 2.
5 on 2.
Okay, so let me go for the dot that we have there indicating the multiplication. The product dot. Okay, so times d dx of what? Okay, so of your here, let's go.
4x minus x squared.
Minus x squared. Okay, you close it. So one more step or 1 or 2 steps, then you are done. Okay, so this will be equal to keep your minus 3 on 2. Keep your
Bracket
4x minus s squared all to the power
5 on 2.
Okay, 5 on 2. Are you sure it's 5 on 2 or minus 5 on 2?
Negative
Minus 5 on 2.
Okay, then times d dx of 4x minus s squared.
4 minus x.
4 minus
2x.
2x.
Hey, be careful. All right, 4 minus 2x. Immediately that is wrong. Marking becomes easier at this point. Okay, so this is a monomial factor, a binomial factor by a pretty factor because the exponent is 1. So you can easily come and multiply. So I will rearrange before multiplying. I'm mature. So this is going to give me minus 3 on 2 times what? 4. So the 2 will go here and give me minuses. Do you agree?
Yes, please.
Yes, please.
Okay, so that is negative. I'm going to shelve it. Let me see. I know that this term will give me positive. So I will shelve my minuses and come and do minus 3 on 2 times 2x. The 2 will cancel, so I'll get plus 3x. Do you agree?
Yes, please.
Yes, sir.
So I will write it maturely as 3x. Okay, then minus what? 6. Okay, then I close my bracket. 4x minus
4s minus
s squared all to the power minus 5 on 2.
Minus 5 on 2.
Let's see. Yeah, done. You get it. Math is so easy. All right. Okay, so this is what we have for this set of what? Of questions. Okay. Point well made, my professors.
Yes, please.
Okay, great. Okay, so now, okay, we are going to, okay, hold on here, have our water break at this point. Okay, then when you come back, you continue. Okay, so welcome back from the water break. All right, so let's look at what we have here. The worked example for our next set of questions. All right. Okay, so this time around, you can see that we have fractions. Okay, basically, okay, the same concept. Okay, just 1 or 2 information, then we'll be good to go. All right, so let's look at the main question, the preamble. For each of the following, find dy dx. So it means all your functions must be labeled y. Okay, perfect. Okay, so now we come and write question, major number question 4. So 4. And those of you who have been writing Q4, what have you, please? The question number is 4. It's not Q4. Just write the number. Okay, then, okay, A. A, what do we have? Y is equal to 1 over 5x squared, okay, to the power negative 1. Okay, this question, we have solved it, okay, indirectly, but, okay, put in a different form. Very soon you agree with me that we have solved it. Okay, so now what do we have? We are going to, with this y function that we are given, okay, is the exponent of what? Our binomial, Claire, is it explicit?
No, please.
No, so we have to make it explicit. So can I say that this is equal to, this is the same as 5x squared minus 1, the whole of that to the power negative 1. Do you agree?
Yes, please.
Yes, sir.
You agree. So you can see that if you go back, okay, this particular question, we have done it. So this question puts in a different form. Okay, let me go back from, I think this is it. So when you write this, the solution will follow. Okay, from there, only that. Okay, so let me continue. So in this case, I'm going to take d dx of both sides. So that will give me, therefore, my dy dx, okay, is equal to d dx of what I have there. My professors, are you with me?
Yes, please.
Okay, and we've done this. So you go back to where we are coming from, then you continue. Okay, you know your answer. That will be it for A. Now let's go and look at that of the B. Okay. B, if you look at it critically too, we have done it. And in this particular question, okay, someone can use the quotient rule. You end up getting the same result. Okay, Prof. Caroline.
Mr. Hackman, please. After solving it, we still have to leave our answer in the form in which it came, like the fraction form, or the
Yes,
way
sure. Sure, you know. As for this one, the B, you know that.
Yes, please.
So if you have as to a certain exponent and the exponent is negative, bring it down. Okay, so let me move up to the last step of the other one. The other one, okay, they didn't come with. So let me go back and let me go and fish. Okay, so this gave us what? Minus 10x. So I'm going to write this then, let you know, okay, the final step in that particular question. So minus 10x. Okay, so so minus 10x, okay, into, okay, 5x squared, okay, minus 1 all to the power negative 2. Is that not it? So 10x, sorry. This is what we had. Is that not it? So it means
Yes, please.
you cannot end with a negative exponent. This came as a fraction form, so you know. You leave the minus 10x as the numerator, so minus 10x. Okay, the one that has the negative exponent is the one that you bring down. And that will give us what? 5, okay, x squared minus 1. The whole of that was squared. Afa.
Yes, please.
Okay, so you get it now. It was a very good question, but maybe I knew, okay, you should be able to know that as well because you've been fed with that information already. Okay, so can we move on to the B?
Yes, please.
Okay, so B, what do we have? Again, we are given y is equal to, okay, 1 over, okay, x minus 2x cubed. Okay, sorry, 2x squared, or cube rather. Okay, so you know the exponent must be explicit before you start differentiating. So this is the same as x minus 2s squared, okay, all to the power negative 3. Do you agree? So it's the same as, okay, the one that we did there. Okay, so if you are taking d dx of both sides, so you get dy dx. My professors, I hope you are following.
Yes, please.
It's equal to d dx of what we have here. D dx of what? X minus what? 2x squared. Okay, then to the power negative 3. So obviously you know, okay, how to proceed from here. Okay, looking at where we are coming from. Where is the B? Okay, only that this one is f of x. So our conclusion will be f prime of x, but it's the same function. Okay, the other one will be dy dx because it was y is equal to. So you end up getting what you have here. But with this one, I think this wasn't the final answer. The final answer is this. So with this one, you write, okay, should I write this one and write the final version? Help you get the final version? Or you are fine?
Please do it.
Okay, all right. So we are not going to do everything. Okay, so you know you continue up to where we have there. Okay, so we are going to get, we had what is equal to minus 3 on 2. Okay, then we had what? X minus 2x squared. Okay, also to the power minus 3 on 2. Okay, I guess that was the result that we had. Was it the same thing? I don't think so.
It was 3x minus 1.
No, it was 3x minus 1. No, that wasn't it. That was the C rather. We didn't do the B. Did we do the B?
We did the B. We did
Okay,
the
so
B.
it means I was referring to. So let me see. Oh, so the B ended where?
12s minus 3.
No, let me see. Maybe we did some multiplication somewhere. Then how come this is the B? Where is the B?
That is for number 4.
I'm coming.
So the one.
Is it this one?
Here is it.
This is it, right?
Yes, sir.
Okay, so this
Yes,
is it.
that's
So
it.
I copied the wrong solution. Okay, all right. So those of you who have it, okay, I guess you can give me. So until we it's simple. Even if it's this one, it's simple. So it will be 12x minus 3 all over x minus 2x squared all to the power 4. You get it?
Yes,
Or I should
please.
still write it?
Yes, please.
Okay, no problem. So let me go back and delete what I was writing. So you help me put the answer for that one. Okay, then we transform it to the form that we want. Okay, looking at the nature of the question. Okay, so Prof. Gideon, I'm coming. Okay, let's learn first. Okay, so here, what did you get? You said 12?
X minus 3.
Minus-
X minus 3.
Into?
X minus
X minus 2x squared.
Okay, minus 2x squared all to the power negative 4, right?
Yes, please.
Okay, so remember this one, okay, there is a denominator. Okay, the denominator had a power. So we have to bring this, because the exponent is negative, we can bring it down, okay, as a denominator and change the sign for its exponent. So this will be kept as a numerator. And because nothing is multiplying, I won't put it in bracket. So it will be 12x minus 3. Okay, all over. Okay, now this comes down because this is what is having a negative exponent, only this one. So you bring that one down, which is x, okay, minus was 2x squared. You put the whole of this in bracket and the exponent will change sign. So it becomes positive 4. Is it clear now?
Yes,
Yes, please.
Okay, so I believe with that, okay, you should be able to do it. So maybe I will transform, okay, the D. Then as a guide, you use it to do the E and the F. Or maybe you transform everything together. Okay, here, Prof. Benji, there was a hand up that I said, Gideon, here, your hand was up first. After that, then Benjamin, you come in. All right.
So
Prof.
please,
Gideon.
so this when we're differentiating the x minus 2 x minus 2x squared all to the power minus 3. So please, when you differentiate the x, you're supposed to get okay. So we're supposed to get 1, but you wrote the. Honestly, please, I've seen it.
Okay, all right. Remember, we've skipped a whole lot of steps there. So that one was dealt with in detail, okay, in the B for this one. Where is it? So this is it. Where is it? Then we came to multiply this and that gave us what we have there. So what is standing with this is not only the differential. So what is here is not only the differential, but is the power of the differential, okay, and the differential of this. Okay, that's what you have there. And you brought the power down and you differentiated when you multiply the two. That gave us this. Okay, all right, Prof. Benji.
Sir, so even if the numerator is 1, you can use the quotient rule to solve it.
If the numerator is 1, yes, you can use the quotient rule.
Okay.
So let's explore and see, okay, how we can use the quotient rule. Should we do that? And see if you end up getting the same result?
Yes, sir.
Okay, so let's try. Okay, pair, what we are doing, you know, is under the composite function rule. So we are using that rule. So this one, you can use but this one even we can use, but we will combine the two. But usually the exponent is 1, and what we have here, did I say the exponent? And the numerator is 1, and what you have here, its exponent is also 1. Then you can use what the composite, the quotient rule. Otherwise, I will advise you not to use the quotient rule. Okay, but the power rule usually, okay, will serve you better. Even in the quotient rule, the assignment that I gave you, some of you, okay, you differentiated, you had the first step, the denominator came. But after that, you ignore the denominator. At that point, you are doomed. In quotient rule, there will always be a denominator in your results. So let me see. I think, okay, you said we should, okay, so let's look at the alternative, okay, to the A. Is that clear? So A, okay, for A, what are we giving? 1 over, sorry, y is equal to, okay, let me squeeze it here, 1 over 5x squared, okay, minus 1. So in this case, I'm going to get, okay, therefore dy dx, okay, will be equal to d dx of that side. In that case, I'm not going to use the power rule. Oh, sorry, the composite function rule. So 1 over 5x squared, okay, minus 1. Okay, so per the rule, please listen. We hold the denominator, which is 5x squared, okay, minus 1. Then differentiate the numerator, so d dx of 1. Is that clear?
Yes, please.
Minus, come and hold the numerator, which is 1. Then differentiate the denominator, so d dx of what? The denominator 5x squared, okay, minus 1. But that's not all. The whole of this one over the denominator squared. So the denominator is what? 5x squared minus 1. Okay, the whole of this one, okay, squared. All correct.
Yes, please.
My professors, I hope you are following.
Yes.
Okay, so
Yes,
now
sir.
this will be equal to, okay, remember I told you without struggle, come and write the denominator first, because that one will be kept intact. You will never work on it. Okay, minus, especially if it's a binomial square. So indirectly, you know that our final answer, the denominator, okay, we've gotten. So this one, you know, this will give us 5s squared, okay, minus 1. Okay, d dx of 1 will give us
0.
0. Okay, then minus, okay, 1 into d dx of this will give us
10x.
10x. Okay, so if you continue, we are going to get, this will be equal to, okay, this will give us 0, right? Then this will give us minus 10x. Okay, all over our denominator, which is 5x squared. Okay, minus 1, the whole of that squared. Okay, if you like, go and check the same result. Afa. So
Yes,
you see
please.
the
Yes,
beauty of
please.
mathematics. Once you don't defy any mathematical principle and you do the right thing, you end up getting the same, okay, result. Safa.
Yes, please.
Okay, so we
Yes,
are going to
please.
look at the D, okay, again from the composite function perspective. Okay, so now D. What do we have? Y is equal to, okay, 1 over cube root of what? 9 minus what? 3x squared. Okay, so we know this will be equal to, so therefore, okay, sorry, we are using the other one, so the exponent should come first before, you have to make the exponent clear. Okay, even this one, I can use quotient rule. If you are mature, you can play with the rules. Okay, so now I'm going to make the exponent. Okay, so this is 1 over, I know that, okay, someone who is not mature will go through the step that I'm writing, which is 9 minus 3x squared, all to what power? All to the power 1 on 3. Do you agree?
Yes, please.
Okay, so the exponent is still not explicit. So though the exponent of the denominator is explicit, but you want to treat this as just a single function. So I can write this as 9 minus 3x squared. I take this one up. Okay, so the exponent will give me minus 1 on 3. Afa.
Yes, please.
Okay, so now I can come and use the chain rule or the composite function rule, and I'll take d dx of that. So I'll come and write d dx of y, so which will give me dy dx. Okay, is equal to d dx of what I have here. Okay, which is 9 minus 3x squared. Okay, all to the power minus 1 on 3. Okay, so at this point, what do? We know, bring the power down, minus 1 on 3 down. Okay, keep your 9. Okay, minus 3s squared. I think this question, I left it for you and I'm doing it. Okay, then minus 1 on 3, minus 1.
Minus 4
Minus 4
on
on
3.
3.
Okay, minus 4 on 3. Okay, then that's not all times d dx. Okay, of what we have in bracket, which is the 9 minus 3x squared. Okay, so in effect, we are going to get, okay, this one must be kept, so minus 1 on 3. Are we following, my professors?
Yes, please.
Then 9 minus 3x squared, all to the power minus 4 on 3. Okay, times, okay, if you differentiate that, what do we get?
Minus 6x.
Okay, minus 6x. Okay, so pretty factor. So now this factor and this factor are pretty, we can multiply. Negative, negative, we know we get a positive result. So let me squeeze it here. So this will be equal to, okay, the positive result, I will write a plus. And you should know that we are going to get, okay, 3 will go into this, and that will give us what? Okay, positive 2. So you get positive 2x, okay, into 9 minus 3x squared, all to the power minus 4 on 3. All correct.
Yes, please.
Okay, so that, okay, obviously cannot be your final answer. You have to take this one down. Is that clear? So let me squeeze the continuation because of the nature of the question. So we are going to get is equal to, okay, so the 2x will be our numerator over, okay, 9 minus what, 3x squared, all to what power? 4 on 3. Is that clear?
Yes, please.
Okay, and the question came with a square root, so we can conclude with our cube root. So I can write this as 2x over cube root of what? 9 minus 3s squared, the whole of that to the power 4. Do you agree?
Yes, please.
Okay, so that then becomes your final. Sapa.
Yes, please.
Okay, so on that note, I think that would be it. Okay, so that's where my target was. Okay, so we are going to bring the curtains down, okay, for this first part of what this lesson. Okay, then I will tell you what we are going to do with the remaining, okay, time. I think 15 minutes or 20 minutes or so. Okay, so on this note, I would want to say thank you very much, okay, for making the class very interactive as always, and for your attention and time. May the good Lord continue to bless us all. Okay, bye-bye.